This is Algebra 1, Lesson 9-4, Difference of Squares. Our objective today is to factor a difference of squares, even with a greatest common factor. So this is a little bit of a review, but remember what happens if we have a conjugate pair. This is a conjugate pair. Conjugate just means that we have the same binomial, but one of them has a plus, one of them has a minus, and there's a pair of them because there are two of them. When we have this conjugate pair, let's multiply and watch what happens. When I multiply a times a, I get a squared. So let's say over here, this is equal to a squared. And then when I multiply my a times negative b, I get a negative ab. When I multiply my b times my a, I get another copy of ab, but this one's positive, so it's going to be a positive ab. And then finally, when I multiply b times negative b, I get a negative b squared. Negative b squared. This is the key part. This negative ab and this positive ab will cancel each other out. So these two are gone, leaving behind the final answer of a squared minus b squared. And you'll notice that is the title of our lesson, is difference of squares. This is a square, this is a square. There's a difference here because there's a minus sign. So what we're doing is we're going backwards today. If you see this pattern of a squared plus or a squared minus b squared, you have to go back to a conjugate pair. So I'll say that in words. If you have a difference of squares, it always factors as a conjugate pair. Okay, so let's go ahead and use this. And I would like to point out also, if you randomly have a plus sign here, then this is unfactorable unless you allow yourself access to that shadow dimension, to the imaginary numbers. But we don't have access to that for any of this unit. So anytime you see a plus sign here, it is unfactorable. All right, so example 1a, we're going to factor x squared minus 81. And I say, oh, that looks like a difference of squares. And how do I know it's a square? Because what I can do is I can set up some parentheses and say, okay, well, this number minus this number, both these can be powers of 2, that both of them can be squares. Well, what number in here squared is x squared? And it's kind of simple. X squared is x squared. And what number squared gives me 81? Well, 9 squared gives me 81. So my two numbers are going to be x and 9 that I'm going to put into my formula of my conjugate pair. My conjugate pair says I'm going to do one of these numbers plus the other number times one of these numbers minus the other number, and I'm done. Typically speaking, we don't show this step. We just say, okay, I can take the square root of x and it turns into an x. I can take the square root of 81 and it turns into a 9. You don't have to write out this step if you don't need to. You can usually jump straight here. All right, let's try example 1b. I just want to point out that I should be checking for a greatest common factor. I'm suspicious of this one because this one has a 9 and this one has a 9. So maybe I can divide by 9 or divide by 3. Let's check for divisibility by 3. So if I add the digits together, 1 plus 9, or 1 plus 6 plus 9, I should be able to see if it's divisible by 3. 1 plus 6 is 7, plus 9 is 16. 16 is not divisible by 3 because 15 is divisible by 3. So 169 is not divisible by 3. Okay, so I can't factor out a greatest common factor on b. So let's go ahead and just figure out what number squared minus what number squared do we have happening here. So I know that I have a c, so this is going to be a c squared, and I have to take the square root of 9 as well. Square root of 9 is just 3. Okay, so I have the first number, and I need to know my square roots all the way up through 20 in this homework assignment. So this one happens to be 14. No, 13, sorry, 13. I need to have my Blue-Kit work. By the way, after this lesson, if you finish early, I would really like you guys to work on the Blue-Kit so you have all of your perfect squares all the way up through 20 done. Do you know what 19 squared is off the top of your head? So there's our numbers. Let's go ahead and turn this into a conjugate pair. I'm going to have 3c plus 13 and 3c minus 13. There's my conjugate pair. We're done. Box. Answer. All right, let's try another example, example 2a. All right. Immediately, I'm suspicious of a greatest common factor because there's a k here and a k here. Okay, there's obviously some sort of greatest common factor. So let's divide both of these by at least a k. I wonder if I can divide by... Okay, this one ends in a 2, this one has a 2. I bet I can factor out a 2k. If I factor out a 2k, what do I have left over? Well, this 2 and this 2 are gone. This k, there's a k to the power of 1 down here, so I just have to do 3 minus the 1 to get a k to the power of 2. K to the power of 2. I still copy down this sign and say it's k squared minus. Okay, now I need to do 392 divided by 2. That's going to be 196, and then these k's are gone, leaving behind just the 196. Okay, so I factored out the 2k. Now I need to rewrite this thing in a better form, so I can say this is going to be times something squared minus something squared, right? All right, well, this one is obviously a k to get the k squared. So what number squared is 196? Again, that's the same thing as asking what's the square root of 196. This one is 14. Make sure you have those perfect squares memorized. And from here, I can rewrite our final form, which is 2k's factored out, and then I have a k plus 14 and a k minus 14. I think now would be a good time to talk about or review the fact that it doesn't have to be a plus and a minus. It doesn't have to be plus minus. I keep doing that form, but just to prove to you that it doesn't have to be that form, I can say it could be a minus and it could be a plus. It doesn't matter the order in which I multiply these. I could put this 2k over here for all you care. Like, it doesn't matter. Multiplication order does not matter. 3 times 2 is the same thing as 2 times 3. All right, let's do example 2b. Okay, I'm seeing that 3 is there. Maybe this one is divisible by 3. I'm not sure. Is 75 divisible by 3? If I add 7 and 5, I get 12. Oh, 12 is divisible by 3. Therefore, 75 is also divisible by 3. Let's factor out the greatest common factor. Let's divide both of these by 3. When I do that, I'm left behind with a 3 times r squared plus... Okay, well, if I have 75 cents and I have 3 coins, that means each of them are a quarter. So 25 cents times 3 is 75 cents. All right, and then it's very tempting to say, okay, well, this one is very, I can say it this way. I'm going to probably erase this in a sec, but you can say it's 3 times r squared plus 5 squared, right? I can go ahead and do a conjugate pair here. No, this number right here is a plus. So it's a sum of squares. The key word being it's a sum of squares, which means it's a sad face, and you cannot factor this. You cannot factor a sum of squares unless you have access to that shadow dimension that I was talking about before. So this, I can't do anything, and I'm going to go ahead and, I guess I'll leave that in the notes, and I'll just cross that off. And this is as far as we can go. All we can do in this one was factoring out the greatest common factor. And sometimes, if there wasn't even the greatest common factor, then you can say that this one is unfactorable. There isn't anything you can do to it. Luckily, we had at least the greatest common factor that we could factor out. All right. Example 3a. We have this thing. Well, I saw the n to the power 4. I was hoping this one had an n to factor out. It doesn't. Okay, well, can I factor out some other number? Can I factor out... Okay, I can't factor out a 2. This ends in a 7. That ends in an 8. Maybe I can factor out a 3. 3s are odd and even 50% of the time. So let's try 3. So I'm going to do some scratch work, and I'll probably erase it in a sec. But if I do 2 plus 7, that's 9. Okay, so therefore 27 is divisible by 3. 7 plus 6 plus 8. If I add these together, let's see if that's divisible by 3. 7 plus 6 is 13. 13 plus 8 is 21. And you can add those digits again if you aren't sure if 21 is divisible by 3. You can say, okay, 2 plus 1 is 3. Okay, so 3 is divisible by 3. Therefore, 768 is divisible by 3. Or it could have also known that 21 was divisible by 3. So each of these can be divided by 3. I think that's probably the greatest common factor. I'm going to divide by 3, and if I'll check again if I can divide by 3 again. Maybe these were divisible by 9. I'm not sure. So for now, let's go ahead and divide by 3, divide by 3, and we're going to get that 3 is the greatest common factor, and what's left over is a 9 n to the power of 4 minus, oh goodness, how do we do that? So 3 goes into 768. This is probably going to be in the way. Let's move you to the side and figure out what you are. 3 into 768. Well, 3 goes into 7 2 times to make 6. Subtract and give 1, bring down the 6. 3 goes into 16 5 times to give us 15. And then bring down 8. 3 goes into 18 6 times, exactly 256 times. So this is 256. Okay, so from here, I'm noticing that 2 plus 5 is 7 plus 6 is 13, and unfortunately 13 is not divisible by 3, so I can't divide out anymore. Greatest common factor was just 3. And that works perfectly because I noticed that 256 is a perfect square. Hopefully you did as well, and if not, you need to practice. You need to go to BlueKit and practice your perfect square. So let's go ahead and rewrite this in the form that will help you guys. This is going to be 3 times this thing. This thing is really something squared minus something squared. And yes, indeed, it is a minus this time. I'm not trying to trick you with a sum of squares. So this is going to be a 3, and okay, this is careful. We have to be careful. 3 squared is 9, but how do I square something to get a 4? And the answer here is 2, because a power of 2 and a power of 2 multiplied, 2 times 2 is 4. Again, these don't add. You multiply those numbers to get that number. So it was 3n squared on the inside here. And then over here, this is just 16. You need to know that the square root of 256 is 16. You just have to have that memorized now that you're in high school. All right, so from here, I'm ready to write out my final answer. And I can say this is 3 times the conjugate pair of 3n squared. I'm going to do a minus first this time. Minus 16 and a 3n squared plus a 16. Nice. And moving on to our final problem in the notes, factor this thing. Holy moly, look at that. I have a variable there, There's 2 giant powers. Can I factor out a greatest common factor on this one? Well, that one ends in a 6, so it's divisible by 2. And I know 16 is not divisible by 3, because if I add 1 plus 6, I get 7, which is not divisible by 3. 49, the only factors of 49 are 7 and 7, and it is a perfect square. So I think we have no greatest common factor. Let's go ahead and just rewrite that. And I'm just double checking. It is a minus sign. It's not a plus sign. So let's go ahead and say that this is something squared minus something squared. Okay, so I'm taking the square root of just 16. Square root of 16 is just 4. Okay, how do I figure out what u goes down here? U to what power? Well, I know that these 2 numbers are going to multiply to 6. So the what times 2 is 6? 3 times 2 is 6. So just double checking. That looks good. Okay, so 4u cubed goes in here. Over here, square root of 49 is 7. And then v. So it's going to be a v to some power. Remember, this power times this power will be 4. So what times 2 is 4? 2 times 2 is 4. And I'm ready to write this as a conjugate pair. So this is going to be 4u to the power 3. I'm going to do plus first this time. I'm just going to be random here. 7v squared. Okay, so that's the first conjugate. This is the other with the minus sign. It's 4u cubed minus 7v squared. And there's our final answer. Excellent. So that concludes notes 9-4 for Algebra 1 on difference of squares. Thank you for watching.